All right, this is Pre-Calculus B, Unit 5, Lesson 6, the second recording in this lesson. I want to address the third and final application of the angle formula between two vectors, which we will give as cosine of theta, cosine of the angle between the two vectors, is the dot product of the two vectors, u dot v, which is a scalar, divided by the magnitude of the vectors multiplied, which is also a scalar. Okay, and so we can use the arc cosine function to find the angle, and that works for angles between 0 and 180 degrees. Okay, the application is in regards to something called work. Okay, work is measured in a unit called joules. And is defined in physics as the force in the direction of motion. In the direction of motion times displacement or distance. Displacement. So, and it's measured in joules, which is Newton meters. Newton is the unit of force, the SI unit of force in physics. And meters is the measurement of distance. You can also express it in foot pounds, but that requires a conversion factor. Okay, Newton meters or joules, if we express things in newtons and meters. So we can express work in foot pounds as well. So be aware that units need to be given in your answers. And so we have this force, but that requires us to have a conversion or an adjustment to the force, because it's the force that acts in the direction of motion. Consider this example. I have a heavy object that's on the ground, and I'm pulling on it with a force here of 200 newtons. Okay, 200 newtons. Or I can pull on it with a force of 200 pounds, if we think of pounds as a force instead of a weight, which it actually is. All right, so a force of 200 newtons, but we're not actually applying 200 newtons of force in the direction of motion. Some of this force is vertical. Some of this force is going to make the box lighter, right? Which certainly would decrease the friction. But what we are interested in is this horizontal component of force. We'll call it force horizontal. Okay? And using a little bit of trig here, if the hypotenuse is 200 and the angle is 32, we understand that the horizontal component is 200 cosine, or I'm going to leave the variables in place. It's the force, the magnitude of the force, cosine of the angle between them. I'll call it theta. Okay. So the magnitude of F cosine theta. So work in this case is the magnitude of F cosine theta. That's the force in the direction in which you're moving times the direction in which times the distance over which you move. So we're going to move between points A and B. Now A and B have nothing to do with the magnitude of the force. It is the distance that you're moving. And so I'm going to indicate the distance between A and B as the magnitude of the vector between A and B. Okay? So the magnitude of the vector between A and B. And let's clean this up a little bit here. So work is the force, magnitude of the force, times the distance that you're moving it through, times the cosine of theta. Now let's go back to this formula. Cosine theta equals u dot v over magnitude v. And let's multiply both sides by magnitude u, magnitude v. We get magnitude u, magnitude v. Okay? and equal cosine theta equals u dot v. Okay, now replace that with these two vectors, vector f and vector ab. So this is this formula, vector f, vector a, the magnitude of vector f, the magnitude of vector ab, which is the distance, cosine theta equals the magnitude or vector f dot vector v. And that is, we've already defined, is work. Okay? And so there are two formulas you can use to calculate work. And that's really the object here. We can multiply the magnitude of the force and the distance over which it traveled times the cosine of the angle between them. So if we have the magnitude and we have the magnitude of the distance and the magnitude of the force vector and the angle between them, in other words, if we're given it to an angular or polar form, we can use this formula. If we're given the vectors in rectangular form, we can do the dot product, right? And that's really kind of a cool little thing. So let's solve this problem here. So let's say AB is magnitude of AB. We're gonna move this box 10 meters along the ground, right? So the work is the magnitude of the force vector, 200, times the distance over which we traveled, 10 meters, times the cosine of the angle between them, 32 degrees. Okay? And the work is Desmos, right? And remember this is to be aware of what angle measure you're using. We're using degrees, so we need to tell Desmos we're using degrees to use the wrench tool. Okay, and let's get rid of this here. So the work is 200 times 10 times cosine of 32 degrees. Oh, come on. Get out of that. Fat finger. Okay. So we do 1,696 joules of work. 1,000, what was it again? 1,696. 1,696 joules. Or Newton meters, Okay, right. You can use joules. A joule is a Newton meter. However, if it's feet and pounds, you just leave it as foot pounds. Okay, so that's the work in that case. Let me give you another case here. What if we have this scenario in which we have rectangular form? So we've got an object on the ground, and we pull on it with a force vector with these rectangular coordinates. So rectangular. So F equals, and let's do it in IJ form. So 4I plus 2J, and the units will be in let's do feet, right? Or pounds, because force is in pounds. Units in pounds. Okay, so there we go. And we are going to move it from point A to point B 50 feet away. $50. Okay. Now we could, and so this vector in rectangular form, by the way, AB, vector AB is going to be 50 horizontally, 0. Okay. And so it's really quite easy here to use the alternate form the dot product of the force and the displacement vector. It should have been dot product of force and AB. Okay, so the dot product of force and AV. So in other words, this is 50I plus 0J. So the work is 4 times 50 plus 2 times 0, okay, which is 200. 200, and this is foot-pounds. Much easier, by the way, if I've given this in rectangular form, much easier than figuring out the angle between them, using the inverse cosine and all of that. And it really provides a convenient way to find the work done. All right, so hopefully that helps.